Welcome to myprojectbazaar.com. Let's discuss about the product. Our product is less is more efficient 3D object retrieval with query view selection. The explosively interesting 3D objects makes their efficient retrieval technology highly desired. Extensive research efforts have been dedicated to view-based 3D object retrieval for its advantage of using two-dimensional views to represent three-dimensional object. In this paradigm, typically the retrieve is accomplished by matching the views of the query object with the objects in the database. However, using all the query views may not only introduce difficulty in rapid retrieval, but also degrade retrieval accuracy when there is mismatch between the query views and the object views in the database. In this work, we propose an interactive 3D object retrieval scheme. Given a set of query views, we first perform clustering to obtain several candidates. We then incrementally select query view for object matching. In each round of relevance, we only add the query view that is judged to be most informative based on the labeling information. In addition, we also propose an efficient approach to learn a distance matrix for the newly selected query view and the weights for combining all the selected query views. We conduct experiments on the National Taiwan University 3D Model Database, ETH 3D Object Collection and shaped retrieval content of non-rigid 3D model. And results demonstrated that our approach not only significantly speeds up the retrieval process but also achieves the encouraging retrieval performance. With the rapid advances in the computer techniques, graphics hardware and networks, 3D models have been widely used in various application domains such as 3D graphics, medical industry, movie production and architecture design. Therefore, efficient 3D object retrieval technologies are highly desired. According to the query type, 3D object retrieval approaches can be divided into two paradigms: model-based retrieval and view-based retrieval. Early methods for 3D object retrieval are mainly model first, and this model-based they require 3D models to be available explicitly. However, in many practical applications, it is difficult to obtain the 3D models of object. An alternative approach is to construct 3D models based on carefully designed set of two-dimensional images. But 3D model reconstruction is computationally expensive and the sampling of image needs to be sufficiently fine-grained in order to generate a reasonable 3D model. These difficulties severely limit the practical applications of the model-based 3D object retrieval methods. Recently, extensive research efforts have been dedicated to view-based 3D object retrieval because of its advantages. By using two-dimensional views to three-dimensional content is making it one of the another advantages. In these methods, a three-dimensional object is described by a set of views captured from a group of cameras, and the object comparison is accomplished by matching two groups of views. In order to improve retrieval performance, several research works also investigated users' relevance feedback. While providing rich information, the plenty of query views also brings difficulties. First, large computational cost is introduced. Generally, the complexity of matching two objects that are associated with M and N views, respectively, will be at least O of Mn. That is, therefore, the computational cost will dramatically increase if there is a large number of query views. However, existing studies on web users show that generally tolerable waiting time for informative retrieval is about 2 seconds. Therefore, waiting a long time after submitting queries will severely degrade the user experience, even if good retrieval result can be obtained. Second, using all the query views is not guaranteed to achieve better performance. In fact, retrieval performance may even degrade if there is a mismatch between the query views and the object views in the database. Some early works have tried to investigate representative view selection and only use the selected views to retrieve 3D objects. However, in many applications, the view selected in an unsupervised manner will not be informative enough in discriminating relevant and irrelevant objects. In this work, we propose a query view selection approach for interactive 3D object retrieval that can improve both retrieval speed and accuracy. It incrementally selects a subset of query view based on the user relevant feedback. Given a query object that is described by a set of query views. So this is our process flow diagram in our MATLAB programming. So initially we have taken in database up to n number of images. That means with similar object and with different angle or different scenarios, but that should be relevant to single object. So we have a single object with n number of images and we are processing matched pixels. That means if there is a object in all images, means there will be a matching pixels in that. So according to the matching pixels, we are identifying the pixels and distance between the points are identifying. Then we are merging the pixels or stitching between two images, and then according to the stitched pixels, we are aligning both images. And then after merging both pixels, we will get common pixels as in center, and right and left column will merge the images. So finally after that we can obtain the constructed image. Let's discuss about the product. So this is the product demonstration. As we already discussed, our product is based on MATLAB programming. So we have used MATLAB 2013A for the implementation of our product. So this is the directory. This directory shows what are the files included in our project backup. So depends upon selected files. You can see the details here. Then this is the command window. This is the workspace command history. So in workspace you can see the mat file which is loaded, and temporary variables you can select and view through the workspace. So you can see there are similar name with the different formats are here. So for example here main.m and main.figure. Main.m represents the MATLAB programming file and main.figure is corresponding to graphic user interface. So when we run main.m, that will call main.figure file. So in main.figure, these are the push buttons. So according to the push buttons, that regarding coding's backup will be in main.m file. So while we are pressing this push button, that process will recall main.figure. So initially I am selecting an input database for the image. For example, I have taken this as an input. So the selected input will be visible in the axis. So and then I am doing 3-dimensional rotation for that. So that is processing. That will take some time to process. So this is the final projected and 3-dimensional rotated image, and we are going to select the image and going to see the different angles, front photo, and then this is the side view, top view, lateral view, and then we are identifying the features. So these are the identified features through this different angles. So mean, entropy, skewness, standard deviation, variation, and then according to the features I am going to retrieve the corresponding image. So these are the corresponding images in the dataset and 3-dimensional view. So this is a 3-dimensional view obtained for given input image. Thank you.